Hey guys, you're welcome back to my channel. This is Chemistry Core. So we take a look at a good topic in organic chemistry, which is what? Formal charge. So when talking about this formal charge, you should have a peroxide knowledge of your valency. So now, what is formal charge? That's the first we should ask ourselves. When talking about the formal charge can be defined as the atoms that assign a particular charge to it in a molecule, or we can say, or they can be obtained from the outer electron subtracted from the unshared electron plus half of shared electron. Or we can say formal charge are charges that has a net charge on either a molecule or an ion. So we look at this particular formula to identify our formal charge. So I said earlier that it can be obtained from outer electron subtracted from unshared electron plus half of shared electron. So is equal to what? Our formal charge. So now, how do you identify this? Don't forget, I tell you guys that there are assigned charges to atom in the molecule now. So for example now, if I tell you guys that my hydrosonium ion is positive, how do we have it? Or I said my CH3NH3 is positive, how is it positive? So now we are going to cite 4 good examples of how we can identify the charge of a particular compound now. So the charge of that particular compound you want to identify are being classified under what we call what? Formal charge now. So example now. So let me take this. I will take these two first. So let's start with hydrosonium ion. So with this now we can talk about the Lewis dot and cross. So we always consider the outer electron only. Don't forget, only consider the outer electron only, because when we talk about the Lewis structure, we talk about outer electron of that particular element now. So when we have this now, the central atom is what? Oxygen. And what is the outer electron of oxygen? 6. And the hydrogen here is how many? 3. So with that I can say that I have one hydrogen is here, the second one is here, while the third one is what? Here. So with that now, hydrogen has one outer electron. You can say that I have one. For oxygen we'll be using dots, while for hydrogen we use cross. So I have this. So now you can see that I've used up my 3 electrons from hydrogen now. So now let's take a look at our oxygen. So this now will be what? Omitted. Why? Because you are going to show your hydrogen here. So don't forget now we have 1, 2, 3, 4, 5, 6. So this is our lone pair. So what really happened here? We have a lone pair bond pair repulsion here. We are not talking about the lone pair bond pair repulsion. So we want to look at the formal charge of this particular compound now. If you have it like this, it's correct. So if putting the outer electron of hydrogen here is wrong. So now with this now I said types of atom. We have 2 atoms here. I have hydrogen. So the next thing is outer electron. Don't forget, subtracted from your unshared electron plus half of shared is equal to what? Our formal charge. So now let's take a look at now. We have oxygen now. The outer electron of oxygen is what? 6. How many hydrogen do we have? We have 3. So in the brackets now, so we can say my unshared electron of hydrogen here is what? 0. Shared, let's count. 1, 2, 3, 4, 5, 6. Because of the hydrogen here, you must count it. It's very, very important. So half of that 6 will give us what? 3. So 3 minus 3 we have what? 0. So for my oxygen now, The 6 will be here. So unshared, this is a lone pair, we have 2 plus. So shared is for oxygen 1, 2, 3, 4, 5, 6. Half of that one will give us what? So I'm sorry, unshared of oxygen is what? 2. Shared is 6. Half of shared will give us what? 3. So we can say 2 plus 3 is 5. 6 plus 6 minus 5 will give us what? Plus 1. So that is the reason why we always have what? We always have what? A positive electron on that. You can see that it's very simple. But if you don't know how to write your Lewis, cross and dots, you might not get this particular thing now. So you can see how simple it is to have your formal charge of this particular element. So let me pick this one now, sulfates. So I will be using this particular table also. So from the sulfates, don't forget that we always consider the outer electron. Sulfur, atomic number of sulfur is 16. So the outer electron is what? 6. Same to my oxygen, 6. So now let's draw it now. I have 1 oxygen here. Don't mind, we have 4 oxygen. I have 1 here. I have 1 here. I also have what? Another 1 here. So now, with what you have here now, the outer electron of each of these is what? 6. 6, 6. So I can say for my sulfur, I'm using cross. I have 1, 2, 3, 4, 5, 6. It's correct like this. So for my oxygen, I'm using dot 1, 2, 3, 4, 5, 6. Here has not completed its octet state, so we'll be adding what? A, another electron there to complete it. So here we have 1, 2, 3, 4, 5, 6. Here you don't have to have any electron because it's completed octet. When you count 1, 2, 3, 4, 5, 6, 7, 8, so that's octet. So here we have 1, 2, 3, 4, 5, 6. See now? So when we count 1, 2, 3, 4, 5, 6, 7, you must add 1 to complete the octet. So we have 1, 2, 3, 4, 5, 6. Here is what completes now. So now, with what you have on the board now, so let's look at the unshared electron of my sulfur, or the unshared electron of sulfur. So when it counts now, sulfur does not have any unshared electron. So we have what? We have 0 plus. So let's count the shared electron of sulfur. So start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So half of 12 will give us what? 6. So 6 minus 6 we have what? 0. As simple as that. So for my oxygen, let's take a look at the word, the unshared. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have what? 20 plus. Are you with me now? So for the shared now, half of shared now will be what? So with that, I can say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That'll give us what? 6. Are you with me now? So with what you have on the board now, it's obvious that we'll be having 26 here as the shared and unshared. But yeah, if you have to subtract it now, you'll be having what? A bigger answer for that now. So how can we justify a case like this? So you look at what you have on the board, either you recount it or not. So that let's go back to that of the oxygen again. So the unshared electron, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We have what? 20. Then the shared is what? 12. And half of 12 will give us what? 6. So you can see a case like this now. We are having a bigger number from the shared and unshared. Are you with me now? But if you are to subtract the outer electron of oxygen from this, we are having what? 20. So now, if you have to have our answer on this now, we can decide to just pick any one from this. Are you with me now? I can just decide to go with this now. I decide to go with this to have my answer. I can decide to go with this to have my answer. So now, a case like this, if you should go in this form, you are getting it wrong. don't forget that you have 4 oxygen. So you'll be adding the 4 here. So he said 6 times 4 will give you what? We have 24. You can see it now. Why? Because you have 4 oxygen that surround the what? The central atom. So you can say 6 times 4 we have what? 24. So it's that now. 20 plus 6 will give us 26. 24 minus 26 we have what? Minus 2. So that is why for every sulfate, or let's say for SO4, we always have what? 2 minus. That is it. That is how you have your answer. So the next one is what? This. I have SO2 now. I want to look at the formal charge of this. So I'll be considering this and this now. I also have CH3 NH3. So let's look at the charges on this compound now. So before we go with that now, don't forget we said you have types of atom. That's the first thing you consider. Outer electron minus the unshared electron plus, we have plus what? Half of shared electron. They have my FC, my formal charge. So now let me consider this now before we move on. So for SO2, your S is central atom. Don't forget that if your S is central atom, then what is the outer electron of what? S, 6. My oxygen is what? 2. Are you flowing with me now? So the same thing we did in the first one, you can say we have 6 times 2. That will give us what? 12. You can see it now. Very, very what? Simple. So the outer electron is what? 6. So I can say that I have 1, 2, 3, 4, 5, 4, 6. I can leave it like this. So my oxygen is what? 1, 2, 3, 4, 5, 6. This 1, 2, 3, 4, 5, 6. So now the lone pair that is the unshared of this one is what? We have 2. The shared is what? 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 will give us what? 4. 2 plus 4 will give us what? 6. 6 minus 6 we have what? 0. So now for oxygen unshared, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 here. Then shared 1, 2, 3, 4, 5, 6, 7, 8. Are you with me now? So half of 8 will give us what? 4. 8 plus 4 will give you what? 12. 12 minus 12 we have what? 0. So SO2 charge is what? We have 0 here. You can see that it's very, very what? Simple. So another example of this is what we have here. So this one is very, very what? Simple, but it's kind of what? Complex. And I'm going to show you guys how to solve it in a simple way now. So the first thing I'm going to do is that identify the types of atom there. The first one I can identify is what? I have carbon, I have hydrogen, I have what? Nitrogen. So carbon is what? We have carbon here. Are you with me? The next one is what? Hydrogen is what? 6. 3 plus 3 we have what? Here 6. My nitrogen is what? 1. So you can see it now. Outer electron of carbon is what? Atomic number 6. Outer electron is what? 4. So my hydrogen is how many now, class? We have 6 now. 1 times to give us what? 6. Nitrogen atomic number 7. Outer electron 5. You can see it now. So now let's take a look at the structure of this particular thing I just said now. So I can say that I have carbon here. I'm using dots for the carbon. We have H3 there. Hydrogen, hydrogen, hydrogen. So the other one, nitrogen, I have this. So I'm using dots for nitrogen. So we have this completed 5 already. So this I can bond together. So I have one hydrogen here, the other hydrogen here. We also have one, another what? Hydrogen there. It's very, very what? Simple. That's how you place your hydrogen there. Because if you have to say you want to place the electron, or we want to show the electron of hydrogen here, it will look more complicated, which is wrong to the rules of what? Lewis structure. So with this now, so for my carbon on shared, you can see it now, you have 0 plus shared. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. That is it. Half of 8 will give us what? 4. 4 minus 4 we have what? 0. So this now, my hydrogen is 6. Are you with me now? So when we look at this now, we can say that our hydrogen does not have anything like unshared. So automatically my hydrogen is what? 0. So the shared is what? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So half of 12 will give me what? 6. So you can see 6 minus 6 will have what? 0. So now back to nitrogen. Unshared is how many? You can see that I have 0 here. Shared. So I said 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 will give us what? 4. So 5 minus 4 we have what? Plus 1. So for every compound like this, that you just find any compound with a charges on it, or a particular net charge on it, or they have assigned it already. So if you want to confirm if truly that compound has a positive sign, it can be positive 1, positive 2, positive 3. So if you want to confirm it now, you can use your formal charge to confirm it, because when talking about formal charge, it talks about the assigned charge on atoms in a molecule, which can be obtained by outer electron subtracted from a shared electron plus half of shared electron will give us one, our formal charge now. So guys, I've shown you guys how to solve or look for the charge of any particular compound given on that formal charge. Don't forget to subscribe, watch, like, dislike, and comment. Thanks.